Earth's core runs at about 5,400 degrees Celsius, near the temperature of the sun's surface, and it's been cooling since the day the planet formed, roughly 100 degrees every billion years. So finish the job, cool it all the way, let the churning iron go solid, and stop it. Your instinct says the ground turns cold. It doesn't. All that heat reaches your feet as 0.09 watts per square meter, about 1 part in 4,000 of the sunlight overhead. So what does a dead core cost you if it isn't warmth? Start with what the core does for you. The outer core is 2,200 kilometers of liquid iron, and it churns because the inner core is freezing onto itself, adding about a millimeter of radius every year. That freezing releases heat and light elements into the liquid above it. The liquid convects, and the convection generates Earth's magnetic field. Your compass runs on an ice cube. Stop the churn and the field doesn't switch off, it leaks away. The electric currents down there take tens of thousands of years to die on their own, so the compass fades across a few hundred human lifetimes. When it goes, the radiation belts go with it, and every satellite in orbit spends its life in raw solar wind, that part you've heard. The bigger loss sits above the core. Earth pushes 47 terawatts of heat out of its interior, and that heat drives the mantle's slow churn, which drags the plates around. Radioactive decay in the rock supplies about half of it, so a cold core doesn't lock the plates the same morning. It pulls the furnace out from under them. Run that down, and the conveyor stops. A planet that stops rebuilding still erodes. Rivers strip millimeters a year off the Himalaya, and with nothing lifting the rock back up, a few tens of millions of years leaves you hills. Flatten the continents, and the water spreads out. Pour today's ocean over a smooth Earth, and it stands 2.6 kilometers deep, everywhere. Here's the twist. The killer isn't the radiation, and it isn't cold from below. It's carbon. Volcanoes are the faucet that puts carbon dioxide back into the air, while rain and bare rock keep pulling it out and locking it into limestone. Switch off the volcanoes, and the trade runs one way. Carbon dioxide drains out of the sky over hundreds of thousands of years. Plants start starving near 150 parts per million. And the greenhouse that holds this planet 33 degrees warmer than bare sunlight. Then the ice finishes it. Less carbon dioxide means colder, colder means more ice, and more ice throws more sunlight back to space, so the loop feeds itself. Strip the greenhouse, and Earth's average temperature is minus 18 degrees Celsius, and a white planet runs colder than that. You end with a flat, quiet, frozen ocean world, under a sky nothing renews. 2 neighbors already ran the experiment. Mars shot its dynamo down about 4.1 billion years ago, and its interior went quiet, which is why Olympus Mons stands 22 kilometers tall. No plate ever dragged it off its hotspot, so one volcano kept piling up. Its air is now 0.6% of the pressure you're breathing. Venus, meanwhile, has no magnetic field at all and holds 92 times Earth's atmosphere. So blame the dead engine for the missing air, not the missing compass. And you don't get to dodge this one. The core keeps cooling, the inner core keeps growing, and the rock record shows the dynamo has been running for at least 3.4 billion years, with billions of years left in it. Mars is half Earth's diameter, so it cooled first. Small planets die young. So, here's the question for the comments. If you had to give up one, would you drop the magnetic field or the volcanoes? Make your case below. And the core is one engine. What happens when the sun switches off its own for a year is waiting on your screen right now.